Okay, and this illustration, this is actually exercise number 31 in your textbook, and I'm going to show you how you'd use what these call a contingency table to do what is called conditional. Let me get the red on here, I like the red. Hold on, let me go back. The conditional probability, and typically that is labeled as the probability of event A. You see this vertical line B. So often it's written as A vertical line B, and that's called conditional probability. So the way I'd like you to look at this, I'm going to write out a formula down here. So if you were to say the probability of A given B, I'm going to give you this as a formula to help you use these tables. The basic idea is you take an intersection, A intersect B, and you divide by the probability of B. Now, just to kind of give you some notes, I want you to label this numerator of this formula to be what I call a joint probability, and I want you to label the denominator, we're going to call that a marginal probability, or I'm just going to say margin. So I want you to think of the basic idea of conditional probability as a joint probability divided by a marginal probability. Now, when you look at this table, I'm going to circle some things here. So if I circle the inner part of this table very delicately here, okay, guys, that's going to be referred to as the joint probabilities. In other words, there's an intersection within the body of the table. So in this case, you have snowboarding intersects with the different types of schools, skiing, and so forth. All right. Now, everything else is said to be in the margins of the table. That's why that's called marginal probability. You've got a marginal probability for snowboarding, for skiing, for ice skating, and you also have a marginal probability for being in what they say junior college, four-year college, or graduate school. So as you can see, you've got some joints and you've got some margins. And typically when you deal with conditional probability, it's always going to be one of these joints divided by something in the margins. It's always joint divided by margin. Okay? So just to go through some basic questions, and just to kind of keep it simple, I'm just going to keep it in the fractions in this problem. Oh, and one more thing, I'm sorry. If you always notice the way these tables are put together, if you were to add this column down, you get 211. If you add the total skiing, you get 171. And add the total ice skating, you get 163. You should notice that if you added these across, that's going to also give you that 545. That's your total number of students in your sample. And then, of course, you could also add these across. 68 plus 41 plus 46 would get you 155. And take the four-year college, 84, 56, 70, add those across, you get 210 and so forth. You'll notice that everything should add up to that lower right-hand corner of these tables. That's your total sample size. And it says right here, you use 545. So kind of keep that in mind. So as you look at, for example, how to answer part A, it says, what is the probability of selecting a student whose favorite sport is skiing? Well, that's not a conditional probability. That's simply a margin. If I look at this table, I know that's going to be 171 because that's my margin out of 145. And you can do the math later, but to get that answer, you just take 171 and divide by 545, and that would be your probability. Very simple. They're not asking, again, for a condition. That's a margin type of question. All right. Now, I go to the next one. It says, what is the probability of selecting a junior college student? Again, that is not a condition. That's simply a margin. And if I look at my junior college, I go to that margin, which is right over here. Notice where it says 155. And so the answer to part B, you'd say that's going to be 155 divided by 545. Again, parts A and B was not asking about conditional probability, but simply asking about the margins. It's not until we get to letter C and so forth where we get to the conditional types of statements. That's this one that I started with in this problem. So on letter C, let's read it. It says, if a student selected is a four-year college student, stop right there, guys. That's said to be the given condition right there. That's going to be the condition. Then they want to know, what is the probability that the student prefers ice skating? Okay, so remember what I said, joint divided by margin. And let me make another note, by the way. That margin is also said to be the given condition. Okay, so the given condition here is four-year college. So four-year college margin is 210. So I can tell you the way you're going to solve your problem here is your denominator is going to be 210 because that's the margin. And then now you just want to find the intersection where it says what is the probability that the student prefers ice skating. So if I'm in the junior college row, Ice skating intersects right there. That's 46. So your answer would simply be 46 divided by 210. Notice that's a joint probability divided by a marginal probability. All right, let's do another one. Letter D says, if a student selected prefers snowboarding, guys, stop right there. That's the given condition. Notice that's going to be our margin. And the snowboarding is right up here. That's 211. So I'm going to go ahead and pencil that in as my denominator is 211. I got that set up. Now I only need to find the intersection. And the intersection they're wanting is, it says, what is the probability that the student is junior college? Well, if I'm in the snowboarding column, junior college is right here. That's what, 68. So that's your joint. So the answer would be 68 divided by 211. All right, now, last one, letter E. It says, if a graduate student is selected, guys, stop right there. Guess what? That's your given condition. So I look up here, where's my graduate? It's right there. I know that's 180. So that's going to be my denominator because that's my given, that's my margin. And then the intersection they want, it says, what is the probability that the student prefers skiing or ice skating? All right, so in this case, you got skiing and ice skating. Notice you got 74 and 47. So you're going to basically take 74 plus the 47. Those are the two intersections they want there. That's your joint divided by 180 would be your conditional probability. So again, I'm just trying to give you a couple illustrations here. I think this makes it, this simplifies it hopefully for you. If you look at a table, think of the body of the table as the joints, the intersections, and everything outside in the margins is said to be the marginal probability. And think of conditional probability as always joint divided by margin, and the margin is always that given condition. Now, one more thing, because this is going to be relevant for the base theorem application. The way you want to kind of read this is like this. Just kind of listen. The probability of event A given event B. All right, so whatever letter you put here, it could be B, A, C, whatever, that's said to be the given condition.